All right, so the next problem, 14, asks us to find f of 5. Now, that means that wherever there was an x in my f of x definition, I plug in a 5. So f of 5 will equal square root of 5 squared. Now, I like to put that in parentheses just because if it was -5, I would need to make sure I was putting the negative inside the square root, but it's not. It's positive 5. Or inside the square, I'm sorry. 5 squared, or if it had been -5 squared. Plus 6 times 5. Okay? So now I'm going to simplify inside my parentheses, my grouping symbol here, which is actually a square root as well. And that's 25 plus 30. And the answer here is going to be the square root of 55. Now, can that be simplified? Well, 55 is 5 times 11. Both of those are prime, and neither of them appear twice. Only if I'm able to factor it into a perfect square or two prime factors that match can I simplify it. So the answer is straight up square root of 55, and there's no other way to write that number. Now, a decimal will not be allowed for this. You can't just plug the whole thing into your calculator and tell me the answer. I need you to know that you simplify what's inside, and the answer is the square root of 55. Any decimal is an approximate answer. So give me this answer. All right, 15. For the given functions f and g, find the requested function and state its domain. So here's an f function. It's a line, x minus 5. Here's a g function. It's a quadratic. It's 2 times x squared. It wants me to find the combination where I add f and g. So I'm going to say f plus g is going to be the function x minus 5, f, plus the g function, 2x squared. Now, when I look in my answers, all of them start with the 2x squared. So I should rearrange this in order to recognize it from the answers. So we put the 2x squared up front. Notice it's positive here, so there shouldn't be a negative. That's the wrong answer. And I'm adding to it x and then subtracting 5. Now it's in standard form, so a multiple choice answer should be identifiable. 2x squared plus x, not that one, minus 5. This looks pretty good. I like this one. This is the correct version of the function. Now the question is, what is its domain? Because this one also has 2x squared plus x minus 5. But does it only exist for all things but 5? Now, we used to take numbers out when it was in the denominator, when we had a problem in the denominator. But this has no denominator. So without any denominator, this is a quadratic, and it has all real numbers as its domain. So the right answer is C. This would be if there was some sort of x minus 5 in the denominator somewhere, but that doesn't show up in our function. So number 16, the concentration C, units don't matter, of a certain drug in a patient's bloodstream can be modeled using this function. So there's a T here. T is the number of hours. So T and hours go together, okay? And if we look at our answer choices for a second, we can see that these are going to be T values. These are all T that we're looking for because they have the unit hours. The C tells you some units, and we're not even sure what those units are. So since a 500 milligram oral dose was administered, using the Desmos graph, find the time at which the concentration of the drug is greatest and round to the nearest tenth of an hour. I will attach the Desmos graph of this, but what I want you to make sure you're looking for in whatever that graph looks like, you are looking for this is our t-axis, you're looking for the x coordinate. So if it says at which the concentration of the drug is greatest, so if there's some sort of peak, we'll want to touch on that on Desmos, and it's going to be this number right here, and there will be some other number we don't care about. But this is the number that'll be the number of hours, okay? Because t is in hours. So you're going to report the x coordinate. All right, I don't have Desmos on this because it's actual paper, so I can't show you that right here. But next problem. Determine whether the graph is that of a function. Is it a function? Function? Question mark. If it is, use the graph to find domain and range. So let's jump to the function, or to the graph here. Now the graph appears to go up and sort of stop here. It might stop, or it might just be getting so close that we can't see it anymore. But either way, it does not appear to come back, right? And so for every x value, it does in fact pass the vertical line test that there is only one output value along this function. And we assume that it goes on forever like that. So since this looks like an asymptote, that it's approaching the axis forever, and it's just very hard to see because it's super close, we're going to assume that action where it gets closer and closer is actually an asymptote at 0. So we're going to say yes, it is a function. Not going to be that one. Now find its domain. All right, well, it's only existing over here on the right. So domain is where on the x-axis it exists. It looks like 0 is an asymptote. So everywhere north of 0, right, greater than 0, but not including 0. So this one works, x is greater than 0. This one works, x is greater than 0. Domain all real numbers? Nope, that one doesn't work. So we've thrown out 2 answers. Now the next one says the range, all right? So the range, well, if this is an asymptote, it's going to go up forever. So positive, it goes to infinity. Negative, this also seems to be trending downward, just slower. But I'm going to say that probably keeps going, and if we go far enough over here, it'll be really low. So it's probably going to be all real numbers as a range. So this one is a check, this one's good, and this one's good, and we've already thrown these ones out, so okay. So the intercept, now looking at this, here's a difference, right? That we have intercepts, but there's also a difference in symmetry. This one says it has no symmetry. This one says it has origin symmetry. So if we were just doing process of elimination, I might look closely at the symmetry and go, well, does that look the same? No, this one's pointing left. Over here, it was pointing to the right. So upside down, it does not look the same, so it will not have origin symmetry. The other thing is, this also says it has the point 0, 1 on it, which is also not true. That point is not there, 0, 1. But the point 1, 0, 1, 0 is there. So this is good, and this is good, and we've verified that B is the right answer. Now we do the same thing for this question, but it's a free response. It doesn't give us those things. So let's use one of the answers up here to give us an idea. Now, is it a function or isn't it? Well, this vertical line, the y-axis, passes through it twice. This is a quick one because this is not a function. And the instructions said, if it is a function, find the domain, range, intercept, blah, 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 do more work. But it is not. So this is the entire answer, right? That was a choice up here. This is our answer right here. Not a function, fails the vertical line test in lots and lots of places, right? It's passing 2 outputs for the same input. All right, this is the last one for this video. Match the function with the graph that best describes the situation. The height of an animal as a function of time. So this is asking you to interpret, okay, how does an animal grow as a function of time? I'm going to think about a person as an animal. I could think about a puppy or a squirrel or something, but it starts very short, right? Very small. All right, well, these all start at 0. This one starts big and gets smaller. So, that's not how animals grow as a function of time, right? That means that this is our time axis. As time goes on, this animal shrinks to nothing. That's weird. But this one grows taller and then gets shorter and shorter and shorter, and at some time it disappears. It goes back to being super tiny. No, that's not how animals grow. They might get a little smaller, but not much. This one says they're going to keep growing forever and ever, slow rate, and then faster and faster and faster, and it'll just get to be giant. That's not right either. So what does this graph say? It says it starts very small, grows fairly linearly, larger, and then at some point it reaches its adult stage and it stops growing taller, right? And us adults like to say we started growing wider instead. But yeah, it stops growing taller and it stays a constant height, right? Once you reach maturity, you have a height that is your adult height. So this is the correct answer for that one. All right, I'll start a new video for the rest.